Now, as you already know that depending upon the type of polymerization, we have two kinds of polymerization. One is the addition one and the other is the condensation. So, now we are going to start with the mechanism that is involved in the addition as well as in the condensation polymerization. So, as I told you that addition polymerization is a technique in which the monomers will just link up and nothing will be eliminated, they will just start linking up and they will form a huge molecule, that is the polymer. So, we have seen that whenever the addition polymerization take place, actually there is a mechanism, there is involvement of mechanism in which the intermediate is formed, right. An intermediate formed is can be a free radical, carbocation or a carboanion. So, depending upon that, if we talk of the mechanism, so we have three kinds of mechanism involved in the addition polymerization. One is the free radical, second is the cationic, third is the anionic. That means when free radical is formed as an intermediate, then the polymerization is called as free radical addition polymerization, and if the intermediate is carbocation, then it is called as cationic addition polymerization, and if it is anion, then it is called as anionic addition polymerization, right. So, now first we are starting with the mechanism, that is the free radical addition polymerization mechanism. So, we have seen here, like you must be knowing that what is free radical. Free radical is an atom which contain an unpaired electron, and it is formed as a result of homolytic fission, in which the both the constituent actually takes the equal loan, this thing, they actually take the shared pair, distribute shared pair equally among themselves. So, free radical mechanism actually involved 3 steps: chain initiation step, propagation and termination. Initiation, where the you can say the catalyst start functioning and where the intermediate is formed, and propagation means when the chain will start linking up and the reaction just speed up, and termination when we just want to wind up the reactions, right. So, we have seen that free radical addition polymerization is basically seen in the case where monomers are basically alkenes. As we know, they are alkenes, so that means they carry an extra bond in addition to sigma bond. That is why the addition is possible in them. You know that unsaturated compounds have a specific property of the addition because they have pi bond between them. So, this mechanism is mainly taken into consideration for the monomers which are actually alkenes, and here the catalyst which function is peroxide, hydrogen peroxide, like that we have a few kind of catalysts, but the most common catalyst which we use is the benzoyl peroxide. So, how the mechanism take place, just look at the board. So, the first step is the chain initiation step, in which what happened, this benzoyl peroxide undergoes a homolytic fission. So, this is my benzoyl peroxide, as you can see here, and homolytic fission, that means equal cleavage. So, it result in the formation of obviously a free radical. So, this is our free radical. Now, it undergoes, we further heat it and finally it form a free radical, this, along with that carbon dioxide is formed. Then this phenyl which is formed, free radical, combines with the monomer, one of the monomer, and form a compound, a intermediate, this. Then this is the chain initiation step where the intermediate is formed and the catalyst break up to form a free radical, and free radical just link up with the monomer forming a reaction intermediate. Now, the reaction intermediate, this is CH2, will combine further with other monomer, let us say one more ethene, and it will give rise to a, means the chain will start becoming longer, but it will still behave as a free radical. See, it's same, I have just linked up these two with these two, and this free radical is still here. And likewise, I can add up n number of CH2, and as a result I am going to get the chain will start becoming longer. And then at last we have the chain termination step, where I take two molecules. Let us take this one molecule, it's 1, 2, 3, 4, so it's 4, free radical. So we say that if we want our monomer to be like this, so we take 2 units of the same kind, and they will just link up and the chain will stop propagating more and the reaction will get terminated. As you can see, we have C6H5, then I have CH2 how many times? I am just going to club them up, 1, 2, 3, 4, 5, 6, 7, 8, let us say, and I will not write 8, or you can write, but the n number of them will repeat itself, and it is this kind of polymer is formed. So as you can see here that in this free radical addition polymerization, first the homolytic fission and then you have a radical, the catalyst, where it combines with one of the monomer forming the intermediate, then it combines with the different monomers, like once it combines with the one monomer, then the compound is formed, then it combines with another monomer. So we just propagate the chain. That means the growth of the chain take place due to addition of many monomers, and when we have sufficient number of monomers, or when we have a sufficient length of chain, actually those two can combine, they can just link up, those both free radical chain can link up, giving rise to a polymer. So this is what is the free radical mechanism of addition polymerization.